Hello, so let's have a look at some examples of factorising. So let's have a look at the first one. We have 3x plus 6. So I set my bracket up. I keep my sign the same in the middle. So I have a plus there. And then I just think, what is common to both a 3x and a 6 term? Well, the only thing that's in common is just a number. It's just 3. There's no letters in common because there's no letters in that second term. Okay. Now say, right, 3 times something that goes there has to give me 3x. The only thing that has to go there is an x. And then I go, right, 3 multiplied by something that goes there has to give me a 6. The only thing that can go there is a 2. And that's it. 3 multiplied by x plus 2. Let's have a look at the next one then. 15x minus 10. So I set up my bracket, bracket. I keep my minus in the same in the middle. And then I say, right, what is common to both of these terms? This is the only difficult step, by the way, asking what is common to both of these terms. Let's have a look. Negative 15x and a 10. Well, the only thing in common is just a 5. There's no letters. So let's have a look. 5 times something that goes here has to give me 15x. The only thing that can go there is a 3x. And then I have a 10 here. So 5 multiplied by something that goes here has to give me a 10. That's got to be a 2. Okay. Have a look at this one then. So I set up my bracket first of all. I keep my sign the same in the middle. Then I say, right, what is common to both of these terms? Well, there's no numbers in common anymore, but there is a letter. It's A. There's an A squared and an A. The thing which is in common to both is an A. So let's pull an A out. Then I say, right, A multiplied by something that goes here has to give me 7A squared. The only thing that can go there is a 7A. And I also say, right, A multiplied by something that goes in my second position has to give me an A. Well, you're kind of like, well, what can go there? Because the A is already there. Well, A times 1. There has to be something there. So the only thing that can go there is a 1. Okay, perfect. So 6ab plus 3a. So let's set my bracket up just like before. Keep my sign the same in the middle. And I say, right, what is common to both these things? Well, there's a number in common now. There's a 3. So I'll pull a 3 out. But there's also a letter as well. If you have a look, there's an a in this term, but also an a in this term. So there's a 3a in common to both of these terms. Then I just reverse expand it. So I say, right, 3a multiplied by something that goes here has to give me 6ab. The only thing that can go there is a 2 and a b, because the a is already out the side, out the front, if you like. Okay, and then a 3a multiplied by something that goes here has to give me 3a. Again, the only thing that can go there is a 1, because 3a times 1 gives me 3a. Perfect. So let's have a look at the next one then. We've got 4ab squared minus 2a squared b. So again, I'll set my bracket up just like before with my sign the same in the middle. So let's have a look. Things in common to both these things. So I have a 4ab squared and a 2a squared b. Well, there's a number in common to both of them, isn't there? There's a 2. And let's have a look at the letters. Well, if you have a look, there's an a in that term and also an a hiding in that term as well. So I'll pull an a out. Then if you have a look, a b squared and a b, thing in common in both is a b. Yeah. So now I've got my factor. I'm now looking to reverse expand it. So 2ab times something that goes here has to be 4ab squared. Well, 2 times 2 gives me 4. The a's already there, don't need to worry about that. But then b times by b makes b squared. Great. Now let's think about the thing over here. So 2ab times something that goes there has to give me 2a squared b. Well, the 2's already out the front. I need an a squared, so I need another a here. And I've already got the b out the front as well, so I don't need to worry about anything else there. So it's just 2ab times 2b minus a. Now, this one's a bit of a beast, so let's have a look at this in pieces. Let's first of all think about our brackets. So put our brackets in here. We'll keep the signs the same. So there's 1, 2, 3 terms, and they're all positive. So I'll keep my pluses the same in the middle. Now let's think about the numbers. So break it down. Think about the numbers first. Well, I have a 15, a 5, and a 30. What's a number that is a factor of all of those things? I think it's a 5. So let's pull a 5 out. And then let's think about the a's now. So we're going through each term and we're looking at how many a's can we pull out. Well, if you have a look, there's an a cubed there, an a squared there, and an a to the power of 4 there. So you're right in saying that there is an a in each of those terms, but I think we can pull out more. We could pull out an a squared. Because if you think a cubed, that's got an a squared buried in it. A squared, well, there's an a squared sitting there. And an a to the power 4, again, that's got an a squared buried inside it. So the maximum that I can pull out as a general rule of thumb is always the lowest power that you can find. Let's have a look and see if that works with the b's as well. So I've got a b squared term sitting there. I've got a b cubed term sitting there and a b to the power of 5 terms sitting there. So using my last rule, it's the lowest power of the b's that I should pull out. In other words, a b squared. Let's check it. Well, there's obviously a b squared hiding there. There's definitely a b squared hiding in the b cubed, and there's definitely a b squared hiding into the b to the power of 5 as well. So there's a b squared that I can pull out as well. And let's just think about the c's then. Well, I've got a c there, a c to the power of 4 there, and a c to the power of 6. Well, the lowest power of c that I can pull out is just a single c. Let's check it. There's a c there, a c to the power of 4 hiding, c hiding in c to the power of 4, and a c hiding in c to the power of 6. Now all we need to do is just reverse expand it. So let's have a think about this. So 5a squared b squared c multiplied by something in the first term has to give me 15a cubed b squared c. So let's think, 5 times 3 gives me 15, then the deal with the a's. So a squared multiplied by something has to give me a cubed, so there's got to be an a there. And then think about the b's. Well, the b squared's already gone out the front, so you don't need to worry about that. Likewise, the c has already gone out the front. So that's my first term dealt with. Now let's have a look at my second term. So that multiplied by something that goes there has to give me 5a squared b cubed c to the power of 4. So I don't need to worry about the numbers, that's already been pulled out. The a squared has also already been pulled out, so don't need to worry about that. But then let's think about the b's. Well, I have a b cubed that I pulled out, b cubed, and I need a b squared I've already pulled out. I need a b cubed, so let's put a b back in there. B squared times b gives me b cubed. Let's think about the c's then. Well, I've already pulled a c out the front, and I need c to the power of 4, which means I must be left with c to the power of 3 there. Let's think about this thing then. For the last term, we have this times this. Well, first of all, I need a 30, so it's going to be 6. Then I need an a to the power of 4. I've already pulled an a to the power of 2 out, which means I'm left with an a to the power of 2. If you like, 2 of the a's have gone, 2 of the a's are left behind. I then need a b to the power of 5. Well, I've pulled a b to the power of 2 out. 2 b's have gone. I'm just left with a b to the power of 2 here. So b to the power of 3 here. 3 b's are left. And then finally, c to the power of 6 I need. Well, I've already pulled 1 c out, so I'm left with 5 c's back there. And that's that horrible monster factorised.